We're back again with Marcus Allen, the UK distributor for Nexus Magazine. Always a joy talking with Marcus, who is a wealth of information, and I always love to do this, is to show Marcus's book.
Wow, look at that. Oh, look, I recognize the name, Marcus Allen, it says here. I've got one of those too.
Very familiar. That's the Apollo Moon Hoax, The Real Evidence.
The Real Evidence, yep.
Marcus Allen and Trevor Weaver. And incidentally, for those of you out there not familiar with Trevor Weaver, he has a few books out now that are really worth reading. I read his first, I believe, 3 books.
Yeah, 3 books.
Yeah, a very good read. He's really done his research, so please check that out as well. So anyway, Marcus, how are you?
I'm well, thank you. Did an interesting Zoom call a couple of days ago with a Dutch group over in Holland, where I did a presentation on the Apollo moon landings, fact or fiction, which if you've seen it online, you've probably seen a similar thing. It went down well. We had quite a good audience, and it's now posted on Vimeo under the Sky High Creations. It's the name of the people who were doing it. And it went very well. Had some very interesting questions, the normal questions. Because I've done it for so long, I can almost tell you what the questions are going to be before they actually happen. And it was the standard one, the one everybody asks. Well, if what you say is true, Marcus, how come the Russians didn't blow the whistle? Which, when you think about it, is a very silly question, because it implies that everybody knew that it was fake. No, they didn't. They didn't know it was fake. The Russians didn't know it was fake. They suspected it was. If you remember, on Apollo 8, the Russians were the first one to send live animals, 2 tortoises as it happened, to orbit the moon. And because they are quite good chess players, they decided to have this little trick, this little joke on America. And they put a tape recorder in their Zond 5 craft. And when it got to the moon, they switched it on, and there were human voices saying, "Oh, look, we can almost touch the moon. We're so close to it," implying that there were astronauts on board. And America fell for it big time. President Nixon was extremely upset. How come the Russians have got people in their craft near to the moon? He asked Frank Borman, who was head of the astronaut office at the time. And they were very upset. Hence, they had to get Apollo 8 off the ground, into the air, and around the moon with their 3 astronauts on board. They'd never tried that before. It was a big risk. And when Frank Borman visited the Soviet Union a few months after the flight of Zond 5, the first thing he said on landing, when he went over to meet the Soviet cosmonauts, he said, "Hello, space hooligans," because they'd fooled the Americans. Oh dear, oh dear. So the Russians knew that they weren't going to do it. The Chinese know they're not going to do it. And they've said as much. And there's a very interesting report quite recently, bringing it up to date, where the Chinese are reported as saying, "We saw traces of Apollo on the moon." This is their Chang'e 2 craft, I think it was. The Chinese unmanned craft, photographing the lunar surface. And the report was, "We have found traces of Apollo." They don't say what the traces are. They don't show any photographs showing these traces, because the Chinese, being sensible people, they don't want to upset America, so they're not going to say it didn't happen, which the Chinese know perfectly well it didn't happen. That's actually taught in their universities at the moment, that America has not landed humans on the lunar surface, because they can't. Nobody can. Look at the trouble America having getting their latest SLS rocket off the ground, let alone into orbit. Maybe it'll go into orbit. It's unmanned. There's nobody on board except some experiments. And guess what? They're trying to find out what is the level of radiation and what will the effect be on ladies. So they've got crash test dummies on board the SLS with radiation meters all over them to measure the effect on ladies. Well, you'd think they'd know all this by now, wouldn't you?
Well, that's a point that I just want to stay on for a sec, because that's a very good point. They're talking about the possible effects of radiation on females. Okay, so that raises a very interesting question, because as you just said, number one, they've been doing this for more than 50 years. The Russians are supposedly have sent up several female astronauts. I mean, they were first to send female astronauts into space, or at least into orbit. So you would think that NASA would ask the Russians for that data to see the effects of radiation on females. Now, they didn't go up more than 200 miles, but the point being, they've had subsequent flights now with missions with several women on board the space shuttle, the ISS. The ISS periodically goes through the South Atlantic anomaly, which can be very intense radiation. So one would think that NASA has enough data on that, so why are they questioning it now? Very good point. Is it because they never went through the Van Allen belts and they're worried about the fact that females being a smaller physical stature may be impacted more? So it is very interesting that that question has come up.
Yeah, it has. It's important to realize that the space station and every other human flight other than Apollo, allegedly, has always orbited well below the Van Allen radiation belts, of which we've heard quite a lot. Van Allen radiation belts started about 500 miles up. The ISS orbits about 200 miles up, so it's within this protective environment offered by the Van Allen belts. And the Earth's atmosphere also protects us right on the surface of the planet. But once you get beyond the Van Allen belts, but beyond about 500 or 600 miles out, going out to about 25,000 miles, the Van Allen belts stop. That's as far as they go, 25,000 miles. But it's then radiation all the way to the moon and beyond. It doesn't just stop radiation. There's radiation all the way to the moon. But if no humans have traveled beyond the Van Allen radiation belts, how do we know what effect it's going to have on them? And as you say, the South Atlantic anomaly, which is an area of radiation which comes down to within about 100 miles of the Earth's surface, can have an effect. When the International Space Station flies through it, which it does on some of the orbits it takes, they have to switch their computers off. Why do they switch their computers off if it gets into radiation? Because radiation damages computers. So you've got all these anomalies in the record, and we've now got the SLS, which is going to launch humans on the second mission. The first mission is just to get the thing off the ground and then into lunar orbit, where it'll stay for, I think we're told, about 30 days, 40 days, quite a long time. And then the second mission, which is due off in about 6 months' time, assuming everything goes well with the first mission, which it hasn't done so yet, the second mission will carry humans, not to land. They won't be able to land because they haven't got a lander yet, let alone test it. They haven't built it yet, they haven't tested it. So they're not going to land, so they're going to send humans into lunar orbit. Well, that is going to be very interesting, because what protection against radiation is carried on the SLS, the Orion, which is the spacecraft, which is going to go. Now, the Orion spacecraft, which is basically Apollo 2.0, just a bigger version of Apollo, but it's covered in heat shield. The whole thing is covered in heat shield. They use the Space Shuttle heat shield tiles, which are the black 3-inch thick tiles, on the spacecraft. Why? They didn't use them on Apollo. There's no heat shield tiles on the upper section of Apollo. The Apollo craft is basically a triangular craft. At the top of it, that's where the parachutes are, and at the bottom of it is where the heat shield is. Now, here's another question which has never been answered. When the Apollo craft was launched, we're told it was launched on top of the service module, which is the cylindrical version below the spacecraft. It's there. The service module is what carried all the consumables and provided the electrical power and the oxygen and all that astronauts would need to keep them alive for a few days in space. That's the service module. It also carried a rocket engine in, and that was the rocket engine that was used to send the craft into what's called TLI, translunar injection. Okay, obviously the Apollo lunar module is attached to the service module. Otherwise it would just sort of float away. It's attached to it. How is it attached? How is the Apollo lunar module attached to the service module? With steel bars through the heat shield attaching the service module to the command module. So when it has to return to Earth, you've got to separate the service module from the command module. So how do you do that? Well, it's simple, we're told. Use explosive bolts which shatter the steel bars holding the command module to the service module, The command module comes off, and that's what returns to Earth. But these bars are put through the heat shield of the command module, which is an essential element of the command module to ensure the safe return of astronauts. Okay, when they're separated, there's what's called a compression pad. This is an Orion, which is the same setup. Orion has what's called compression pads. That's all they're called. They don't explain how they work, but what they're supposed to do is to seal the hole made by the steel bar connecting the Orion command module to the Orion service module. And there are pictures of it. They exist. There are 6 of them. Supposing one of those compression pads doesn't seat properly, supposing it doesn't go into the hole correctly, how would they know? Are the sensors? And what would they do if it didn't seat properly? You would get a similar situation to the Challenger disaster and the Columbia disaster, where the heat shield was penetrated by the frozen oxygen hitting the heat shield on Columbia. Yep. You would get disintegration of the spacecraft because the heat generated, thousands of degrees centigrade, would burn straight through the aluminium of the craft, set fire to the interior, incinerate the astronauts. And you don't want that to happen, obviously. That's why the heat shield exists.
Very quickly, too. That would happen very quickly. That happened almost instantly.
Yeah, it did. Yeah. Fortunately for the astronauts, it did happen very quickly.
Yeah. I have a question, actually, about the Van Allen belts. We'll get back to that one a little later. I want to stay in this subject right now. You were talking about the explosive bolts on the command module. That's something that I've thought about myself. Was it on the command module you talked about, or on the SLS, the Orion?
It's the same on both of them.
Okay, we're talking about both, yeah. I just wanted to know if you're specifically talking about one or the other, but yes, they're on both. You raised another interesting point in terms of the sensor. So using explosive bolts, being mechanical and technology, is always the potential of a problem. So my question is, and I haven't found an answer to this, how would the Apollo astronauts, and presumably the Orion astronauts, if and when they go, how would they know upon re-entry, before re-entry, that the explosive bolts didn't do any damage to the heat shield? Either underneath in the Orion case, well, of course, in the Apollo case, the heat shield underneath, because there was no heat shield on top, as you pointed out. But there's supposed to be now on the bottom and on the top of the Orion spacecraft. Either way, either mission, how would they have known whether there was damage done? That's the first part of the question. The second part is, what is the contingency if there's damage done to the space shield from the explosive bolts, from the separation of the command module from the service module? You see, this is one of the aspects, Marcus, that you and I have talked about many times, and that I have written in my books, is there is no redundancy. You have no redundancy in these systems, and you have no real means of rescuing a mission that's a manned mission outside of the Van Allen belts. They're on their own. So there's a two-part question is, number one, how would they know that there was damage done to the heat shield from the separation from the command module, command service module? And number two, what would be their backup plan to compensate for that?
Okay, there's no backup plan. There's no means of identifying if there has been damage.
Yep.
And we can quote the original flight of Columbia in 1981, very first flight of Columbia as a space shuttle. 8 years after the last flight of Apollo. What's so great about the space shuttle? If Apollo could do everything we're told it did, the space shuttle can't get out beyond the Van Allen belts. Anyway, the very first launch of the Columbia, there was considerable anxiety at NASA that the vibrations of the launch would shake loose some of the heat shield tiles on the space shuttle where the astronauts were. And sure enough, when it launched, it was noticed that there were heat shield tiles, which are glued onto the space shuttle, detached. What they didn't know at the time was that were these in such a dangerous position that it would require the space shuttle to be aborted. Quite what they would do if they decided to, because there weren't any parachutes on board. What they did to determine whether there were detached heat shield tiles on the very first flight of Columbia, they intercepted the Columbia orbit, this is a low Earth orbit, with a spy satellite called Hexagon, the KH-9. which is on a polar orbit. They intercepted the two flights so that the hexagon could photograph the Columbia. Photographs would then be transmitted down to Earth. They were digital photographs by this time, not the original photographic film. Here is the original photographic film. That's what they originally used, but it was switched to digital in 1981. So if you're going to come in on a spacecraft, whether it's a space shuttle or a command module like the Apollo or even like Orion, or even the Russian craft, Soyuz craft, they bounce off the atmosphere. What the Russians did was to have a skip re-entry. Hit the atmosphere, bounce up a little bit and come down. It's like skipping stones across a pond. The stone eventually slows down, as the spacecraft would slow down. But America couldn't do a skip re-entry. So they obfuscated it and called it a double dip entry. Not very clever. Basically, they couldn't control the spacecraft with the precision they required to do if it had this skip re-entry. Double dip and skip re-entry are basically the same thing. The more you can slow it down, the better. It's entering the atmosphere at 17,500 miles an hour from low Earth orbit.
Yeah.
Apply the inverse square law. You increase the speed by 50%, you double the energy. So you've got to dissipate twice the energy from lunar orbit as you have from low Earth orbit.
NASA astronauts themselves kind of muddied the waters when they were talking about direct, skipped, double dip reentry. They were never very clear. In fact, I have documented some instances where they were contradicting themselves. Everybody knows anything about basic orbital mechanics. You need a skip reentry to peel off the energy from the spacecraft. You've got to peel off that energy, that speed, that energy, so as it can enter safely for its design configuration. When some of the Apollo astronauts, and exactly who right now escapes me, but have sort of given mixed messages on that. Now, this is something that one would think that they would be all in agreement on, and they would all have their facts straight on and be reading from the same script, but it doesn't seem to be that way with the Apollo astronauts.
No, it doesn't. There's an interesting account published on the AULIS website, that's AULIS, of a gentleman who visited Autographia, where celebrities and film stars, TV stars, in this case astronauts, would visit. In Britain this was. Astronauts would sell their autographs at $200 a hit. They could make quite a lot of money, so they would be very welcome to come over. And obviously they had to give presentations themselves, and they had to answer questions. And one of the questions was about this re-entry. It was a point raised by David Albell, who was a persistent questioner. And he questioned Al Worden, who was the Apollo 15 lunar module pilot, I believe he was. He was quite vitriolic. He said, talking about Gene Kranz, the mission commander, I believe it was, he said, if we could feed Gene to a bomb, we would. What an extraordinary statement to make. That's a death threat, basically.
That is a death threat. I put that in book 2. With all due respect to the Apollo proponents out there, and this is just a sidebar issue, you want to condemn Alice, then do it with your own evidence. Don't do it from an emotional-based point of view. Emotional-based point of view is good in certain instances. There's no doubt about that. But they're saying, and they documented what you just mentioned, and what I wrote in my book. Alice did the investigation on that, and no proponent's ever been able to defend that, because that is a threat. Now, in this day and age of the political climate that we're in, the FBI would be at your door.
Yeah.
Right? And that was a serious threat coming from an astronaut, an Apollo astronaut, an alleged Apollo astronaut, an American hero, a role model for not only his own country, but for the rest of the world, comes out and threatens somebody. And that was not a joke. That was a serious threat.
Yes, it was.
This is the kind of nonsense that I think not only annoys us, Marcus, but it annoys a lot of people when it comes to these missions. Do not dare question these missions. Do not even hint that these missions may be a problem in terms of trying to validate it, because you're going to get the wrath of the security forces on you, so on and so forth. I digress here, but you know where I'm going with this.
Oh, yeah, yeah. Well, maybe not security forces directly. Maybe they're proxies. who can be encouraged to attack anybody such as yourself, such as me, such as all the others who do, Jarrah White, Scott Henderson, Robert, Bart Sibrel, all these people, they've been seriously attacked for daring to suggest that what they have identified in their own research, which is very extensive, are questions that have yet to be adequately answered. Now, I say that no human has walked on the lunar surface. Prove me wrong. Yeah. There is so much against that being real, such as the ability of humans to survive the radiation levels that we know exist in space, yes, without any protection, to survive the levels of vacuum in space without any protection, and also to survive the levels of heat they will be experiencing in space, the radiant energy of the sun.
We as human beings, so we have been breathing in this atmosphere, which is 21% oxygen and then the rest nitrogen and some other ingredients, okay? So that's how we're brought up from birth to old age. So what are the consequences, if any, of breathing in, prolonged exposure to breathing in almost 100% pure oxygen? For example, with the Apollo missions where they were in orbit for like several days breathing in oxygen. Number one, what are the ramifications of breathing in that oxygen combined with the heat that they would have had to have dealt with in the environment of space? All these factors. You don't need to be a doctor or a medical scientist to actually think about these questions and ramifications. Do you know of anything, Marcus? Is there any long-term effects from breathing in pure oxygen over a prolonged period of time?
There would be, yes. But the key difference, the key factor here is the pressure under which you're breathing it.
So we're talking, I believe it's 5 pounds per square inch?
4.8 pound per square inch. That's the declared pressure. Now that is the same pressure as we would experience if you're on the top of Mount Everest. Because pressure decreases the higher you go.
Right.
Which is why when you get to space, there's no pressure.
Okay. So that explains the need, of course, for more oxygen per cubic feet. If you have less pressure, you need to get that oxygen into the bloodstream.
Yeah, you can certainly breathe pure oxygen at a lower pressure than we would experience here on Earth at sea level, 14.7 pounds per square inch. If you breathe it at that level, it would have the same impact on you. It wouldn't cause problems. If you breathe it at a higher pressure, yes, it can cause problems. As any doctor will tell you, you've got to maintain the pressure and the concentration of the oxygen within very close limits. Otherwise, you will cause damage to lungs.
I'll go with the official narrative. We have astronauts on the ISS for several months at a time, and they don't apparently seem to show any effects. Is the ISS, does that use the same environmental approach controls as they did with the Apollo missions?
I think the pressure is higher. So the concentrations vary slightly. As you say, 80% of the atmosphere we breathe is nitrogen, which is an inert gas. In round figures, 20% is oxygen. And there's a trace elements. There's the famous carbon dioxide, the control load of the world's temperature, 0.04%. But let's say, forget that for the moment.
Yeah.
Oxygen is 19 to 20% of the air we breathe. If it becomes less than that percentage, if you increase the pressure, you won't find any difference. But within that parameter, we would have to have it at that sort of pressure we get here on Earth. Which is why when you climb Mount Everest, very few people can actually get to the top without additional oxygen. And if you go higher than Mount Everest to where jetliners fly 35, 40,000 feet, if you stick your head out the window, well, don't, but if you did, you wouldn't be able to breathe because there isn't enough oxygen, let alone enough pressure to force it into your lungs against the back pressure of your body, which operates at around sea level periods. It can't absorb enough oxygen, which is why if you get people who are born and are acclimatized to living at, say, 5,000 to 6,000 feet above sea level, like in Kenya or Ethiopia, when they come down to sea level, they can absorb much more oxygen because they're used to much lower level or much lower pressure of oxygen. Is why they're such good runners.
This is getting very interesting because, again, we've had astronauts on the International Space Station for several months, and they seem to have apparently done okay. So was it 6 months, 7 months, or 8 months? They come down, they don't seem to have any serious after effects, except, of course, for the being in a non-gravity environment. What I want to know is, has NASA done experiments before they sent these astronauts into space? Now, given the fact that I understand that fully, that you can breathe oxygen into the lungs, oxygen can be transferred from the lungs into the bloodstream at an altitude of 200 feet at approximately 5 pounds per square inch. I got that. Did NASA actually run trials on human beings before they sent them into space and had them in an environment where it's which would be very difficult to duplicate here on Earth, presumably so. I don't know the details of that. But have they actually had astronauts spend several months in a facility breathing 5 pounds per square inch of oxygen for 2, 3, 4, 5, 6, 7, maybe 8 months at a time, like before they send them into space? Because how would they know the long-term effects? I'm still thinking there must be some long-term effects. You know where I'm going with this. Yeah.
Oh, there are long-term effects.
Yes.
I think, was it Scott Kelly? Was an American astronaut. He spent a year on the International Space Station. And because he has a twin brother, he's called Mark, they were able to show the difference between the two individuals, the two brothers, because they could examine them both and they know what the conditions were. Now, if you're going to be on the International Space Station, they could simulate that pressure quite easily. There is a facility in Ohio called the Glenn Research Center. It's a vast vacuum chamber, about 100 foot high. There's 8 foot thick walls, because at a total vacuum, you're getting a lot of pressure. 14.7 pound per square inch times whatever it is, it's many hundreds of tons of pressure, so it has to have strong walls. If you only reduce the pressure down to 5 pound per square inch, let's say height of Mount Everest, and feed in the required amount of oxygen, you could easily identify any problems, because you could walk around inside this facility quite easily. But they never did that.
Okay, that's the point that I wanted to hear from you. Why wouldn't they do that first? Okay, my point is, if you send an astronaut up to the ISS and they're there for several months and anything happens to the astronauts because of the prolonged environment that they're in, exposure to the environment that they're in, they can't get them down on time.
No.
Why wouldn't NASA run that program here on Earth before they actually ran it in space?
The only thing they can't simulate on Earth is the reduced gravity. On Earth, you've got standard gravity. 9.8 meters per second squared. That's gravity. In space, there's very little gravity. There is some gravity.
Microgravity, yes.
Microgravity.
Yeah.
The International Space Station is orbiting the Earth about 200 miles up at 17,500 miles an hour, and that's what keeps it in place. That's a very hard thing to simulate on Earth. And if you've ever seen photographs of astronauts returning from the International Space Station, usually on the Soyuz craft, they can't walk when they get back to Earth. They have to be lifted out of the Soyuz craft, put on a stretcher so that they can speak. They can still speak, okay, that's all right. But their body has been seriously affected. It recovers in a few days, but this is after maybe 3 or 4 months in the International Space Station. They can't walk. The body won't support themselves, no matter what the exercises they do. So what chance of getting any humans from Earth to Mars, and when they get there, after 18 months of flight, being able to do any sensible work at all, and then another 18 months to come back? Forget it, it's never going to happen.
You just hit the point that I was looking for.
Good.
Okay? And I know that I'm going to get emails when I say this, and you're going to get emails, and people are going to say, here they go again.
Yeah, come on.
It's another hoax, right?
Yes.
Mark Kelly was in space for how long?
A year.
Okay. I know what I saw, and everybody knows what they saw. 3 days after he came back, I saw him. It was right on the national news, the mainstream media, not walking down the steps from the plane 3 days after his trip to space for several months. He literally jumped down the steps. He was jovial. And what crossed my mind, what I immediately thought about, Marcus, what I immediately thought about is, how is it that this man, who was several months to a year in space, have the muscle capacity to sprint down those stairs from the airplane to the tarmac?
Good question. You're obviously a very fit man.
I remember I turned to my wife and I said, "Are you seeing this?" She said, "Yeah." And she didn't understand at the time. And I explained it to her and she goes, "Well, that's interesting." And anybody who wants to doubt me, you can look that up on YouTube. You can find that anywhere. There's many videos of Mark Kelly is one of the few who are not being censored, right? They can look that up and then you email me and you explain it to me.